Okay, let's get right into this. Welcome to this explainer on physics exam strategy. Today, we are completely decoding the top band approach for the Cambridge IGCSE Physics exam. Picture this. You have exactly 20 minutes before your mock exam kicks off. Are you actually ready? Now, what's kind of crazy about this high-stakes scenario is that ordinary revision, just passively memorizing textbook facts, is quite literally the fastest way to drop critical marks. Because when you're sitting there in that exam hall, knowing the physics, well, that's really only half the battle. The other half, the part that actually secures your grade, is knowing exactly how to translate those concepts onto the paper. If you just dump a bunch of memorized facts onto the page without structuring them the way the mark scheme demands, you are leaving incredibly easy marks on the table. So, how do we prevent perfectly good physics knowledge from just getting totally wasted? It all comes down to decoding the precise strategy that prevents those devastating mark drops caused by a lack of command word awareness. You see, the examiner isn't just checking if you know the science. They're actively checking if you know how to answer their specific question. Ordinary revision completely fails because it ignores the actual phrasing of the exam. When a student misreads a command word or kind of fails to recognize the depth required by the question, their perfectly good knowledge gets thrown right out the window. The secret to fixing this, it's what we call the top band framework. Think of it as a 4-step funnel for exam success. Step 1, identify the core concept. Step 2, pull the exact evidence or data from the graphs or tables they give you. Step 3, apply your scientific reasoning to connect that data to the concept. And finally, step 4, package the whole thing using the exact examiner wording dictated by the command word. Funneling your knowledge through these 4 specific steps ensures you directly hit the exact wording the examiner is begging for on their mark scheme. In just a second, I'm going to reveal the ultimate examiner clue that changes your answer completely. It's a secret that dictates exactly how deep your reasoning actually needs to go. But first, we need to establish the foundational framework that makes that clue entirely obvious. Because let's be real, if you don't have absolute command over your core numbers and units, even the most beautifully structured answer is going to instantly fall apart under scrutiny. Which brings us to Section 1, Mastering Metrics and Measurements. Look, without absolute precision in your metrics, that entire top band framework we just talked about instantly fails. Think about the practical data analysis sections of your paper. The examiners are rigorously testing your ability to handle real-world physics measurements, and they expect strict, zero-compromise adherence to exact SI units. So you absolutely must routinely convert common metric prefixes, like milli, kilo, or mega, back into standard units, like meters or kilograms, before you even think about touching your calculator. If you plug a distance in millimeters straight into a speed calculation without converting it first, your final answer is wrong, period, no matter how perfect your formula was. And hey, remember this golden rule for significant figures. Always round your final calculations to 2 or 3 significant figures to secure those easy marks. Writing down the entire string of 10 digits that pops up on your calculator screen, that doesn't make you look smarter. Actually, scratch that. It's a massive trap that shows a total lack of practical data awareness. In the IGCSE Physics exams, keeping your final answers clean, concise, and scientifically appropriate at 2 or 3 sig figs is exactly what the mark scheme is waiting to reward. Okay, let's move right along to Section 2, Flawed versus Perfect Answers. We've covered the theory and the absolute necessity of precise metrics, but let's escalate the stakes a bit and see this in the heat of a complex velocity time graph question. Before we break it all down, I want you to mentally pause for a second and predict exactly where a typical student loses marks here. Imagine the student writes this. The line goes up, which means it gets faster because there is a force. I mean, it sounds like physics, right? But it scores terribly. So where exactly did they go wrong based on our 4-step funnel? Keep your theory in mind as we reveal the truth. Notice how the flawed student answer just casually lists facts? The line goes up. There are no exact metrics, absolutely no standard units, and definitely no deep scientific reasoning. Now contrast that with the perfect top band application. It tightly connects the evidence to scientific reasoning using our exact framework. It identifies the concept of constant acceleration. It pulls exact data right from the graph with perfect SI units. It applies scientific reasoning about unbalanced forces. And best of all, it uses formal examiner wording. It is literally a night and day difference. This examiner-style feedback shows exactly how the improved answer flawlessly hit every single requirement of our 4-step funnel. Imagine the examiner physically ticking off the marks. Bam! 1 mark for correctly identifying the physics concept. 1 mark for extracting exact numeric data. 1 mark for linking that data to the underlying scientific law. And the final, absolutely crucial mark for providing the exact depth of reasoning that the specific command word in the prompt actually asked for. And here is the resolution to that cliffhanger from earlier. The secret examiner clue always lies in matching your reasoning depth directly to the command word used. It's that simple. If the command word is describe, you just state what is happening. For example, the speed increases. But if the command word is explain, well, then you must provide the scientific reasoning. The speed increases because a resultant force is acting on the mass. The command word is the hidden key that dictates exactly how far down the four-step funnel you need to go. If you ignore it, you lose. But this leaves us with a pretty critical unresolved problem, because knowing the framework is only half the battle when a complex evaluate question suddenly hits your desk. Evaluation questions are the ultimate test of your nerve, and for sure your exam strategy. You're asked to look at a practical investigation design, weigh multiple conflicting variables, and make a definitive, solid judgment. Panic is the completely natural reaction when you see a massive 6-mark evaluation question staring back at you, totally threatening your grade boundary. So, to survive the rest of the mock exam and master that top-band evaluation framework, you've got to take the mandatory next step. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to completely excel in your Cambridge examinations. The mock survival plan continues right there, where we decode exactly how to crush those final, super intimidating evaluation questions. But before we wrap up, ask yourself this. If an examiner looked at your most recent practice paper right now, would they see a messy brain dump of memorized facts or a flawless top-band funnel?